Before commencing any work on a suspension system, you must be aware of the dangers associated with working on and under vehicles, as well as the safeguards to consider when using equipment on suspension components. Remember, many of these components may be under considerable load and could be supporting the vehicle's weight. Customers have come to expect that the suspension system on their modern vehicle has been designed to cater for best handling, ride comfort and load carrying. But is this always achievable or even possible? When we consider the suspension system on a modern vehicle, it must be designed to accommodate a number of factors that ensure safe and reliable operation under all conditions. This is a first in a series of videos covering suspension systems. Keep a lookout for our other in-depth training modules. The suspension system on a vehicle needs to support the vehicle's weight and any load applied while at the same time maintaining ride height. It also needs to minimise the shock forces acting on the vehicle and at the same time maintain correct wheel alignment under all driving conditions. So, in essence, the requirement of any suspension system is to maintain the best possible contact between the tyre and ground regardless of load and driving conditions. From a safety point, the suspension system needs to control vehicle direction of travel under all conditions, including acceleration, braking and cornering, as well as the transition of driving and braking forces from the wheels to the vehicle's frame. Designing suspension systems to control these forces is often a conflicting task. These factors are tackled in different ways by each vehicle manufacturer, with the final design often requiring some level of compromise. This is to achieve a vehicle setup that meets the requirement of the marketplace at a specific price level and targeted to a vehicle segment. You cannot successfully steer, brake or corner on a tyre that is not contacting the road surface. In light of this, let's look at what we mean by sprung and unsprung mass in a suspension system. The sprung mass is any mass supported by the suspension system. This would include the vehicle's body and any passengers. Whereas unsprung mass refers to any vehicle mass that follows the road surface contours and includes such things as tyre and wheel rim. Various forces are at work on a vehicle whilst it's in motion. Being able to effectively balance these forces is the main responsibility of the suspension system. Forces are imparted on any vehicle during acceleration or braking, when driving over bumps or during cornering, or even when driving over a crest or through a dip. And as you can imagine, these dynamic forces vary widely, depending on the type of road surface, the actual driving conditions, and how fast the vehicle is travelling. These forces will affect the vehicle in different ways. A vehicle accelerating will experience weight transfer to the rear, whereas under braking will transfer forward. Suspension components designed to control these forces will also be affected and will stretch, compress, twist and roll. In simple terms, an applied force is either a push or pull force acting on an object. There are 5 common types of applied push and pull forces used in a suspension system: tensile, compressive, shear, bending and torsion force. Tensile force is often described as a pulling or stretching force. A suspension retaining bolt uses tensile force for security with the bolt under constant tension. Compressive force is a force pushing inward to compress an object from the outside. A suspension coil spring will experience compressive force when load is applied. Shear force is the result of 2 push or pull forces acting against each other, but not directly opposite. Shear force is seen at the sway bar link pins. These experience opposite push and pull forces as the suspension moves over bumps, thus causing a shearing force to be applied. Bending force is a deflection when it's either pushed or pulled. This is evident in a leaf spring that will deflect via bending force when weight is added or removed from a vehicle. Torsion force is a result of a twisting force being applied to one or both ends of an object via a lever that is pushed or pulled. This is readily seen in a vehicle fitted with torsion bar suspension. There are different types of suspension springs used in automotive vehicles that use the force principles we have just seen, ranging from coil, leaf, torsion, rubber, hydraulic, and even air. Every spring has a spring rate, which is a measurement of a spring's resistance to deflection, or to formation when a load is applied. The spring rate may be constant or variable, dependent upon the vehicle's intended use. Constant rate springs will compress at a constant rate regardless of the applied load. This results in a spring that may be too stiff in light operating conditions, or one that is too soft for heavy conditions. However, variable rate springs are able to be soft in one region and then become more firm as load is applied to the vehicle. When there is a light load on a variable rate spring, its rating will be deemed as soft. As the weight or load is increased, the spring rate rises, which enables additional load capacity while maintaining the vehicle's handling characteristics. The shock absorber or dampener in a vehicle's suspension system is used to control spring deflection. A loaded spring will oscillate and bounce if not adequately controlled by a shock or dampener. When attached to the suspension system, the shock absorber uses hydraulic principles, creating a dampening effect to control the spring oscillations. In effect, the shock absorber slows down the spring oscillations, helping to control the bounce felt by vehicle passengers and maintain vehicle stability by keeping the tyre in contact with the road surface. A working shock should be able to reduce the spring's oscillations to around 1.5 cycles. These principles are the foundation for OEM and aftermarket suspension systems. Having a firm grasp of these concepts is vital when it comes time to diagnosing or repairing these systems. Thanks for watching. Bye for now.